The Singleton method design pattern ensures a class has only one instance and provides a global access point to it. It's ideal for scenarios requiring centralized control, like managing database connections or configuration settings. This article explores its principles, benefits, drawbacks, and best use cases in software development. Below are the principles of the Singleton pattern. Single instance. Singleton ensures that only one instance of the class exists throughout the application. Global access. Provide a global point of access to that instance. Lazy or eager initialization. Support creating the instance either when needed, lazy, or when the class is loaded, eager. Thread safety. Implement mechanisms to prevent multiple threads from creating separate instances simultaneously. Private constructor. Restrict direct instantiation by making the constructor private, forcing the use of the access point. Singleton class can be instantiated by two methods. Early initialization. In this method, class is initialized whether it is to be used or not. The main advantage of this method is its simplicity. You initiate the class at the time of class loading. Its drawback is that class is always initialized whether it is being used or not. Lazy initialization. In this method, class is initialized only when it is required. It can save you from instantiating the class when you don't need it. Below are the main key components of Singleton method design pattern. While creating Singleton class, we create a static variable that will hold the Singleton object. We do this so that there would be only one copy of the object for entire application. Next, we create a private constructor. This private constructor will not allow object to be created anywhere else other than its own class. Next, we create a static method called getInstance. This method will check if a Singleton object is already created or not. If the object is already created, then it returns that object, but if it's not created, then it would create one. This is possible because the variable is static and once it's assigned an object, it is the only single object in the entire application. So we simply check for its presence. If it's present, then return it or else create new object. In the complete code for Singleton class, we see that we have static variable instance that will hold Singleton class object. Since it is static variable, we only have one copy of the object for entire application. So if the variable holds any object, that means it won't be created again. Next, we see that a static method, getInstance, is creating the Singleton object, but first it will check if already exists. If not, then it will create. But if it exists, it will return the object. The other methods to create Singleton object is as below. In this method, we simply add synchronized keyword to the static method getInstance. So now only one thread would be able to access the method at a time. In the eager instantiation method, we create an object directly when we declare the static variable to hold it. In this way, as soon as the class is loaded, we create the Singleton object. In the most efficient method, that is double-checked locking method, we keep everything same, but we double-check the object inside the getInstance method. If the variable is null, then it will create an object, but if it is not null, then the object in the variable is returned. Here we also consider that if a thread is already accessing the getInstance method code, then no other thread should access this getInstance method code. Also, if the thread sees that the variable is not null, then it will skip the unnecessary code and will return the object in the variable. In the instantiation through inner class method, we see that we have a static inner class Singleton inner, and we have a static final variable instance, which is holding a Singleton object inside of the inner class. Also, we see that the static getInstance method returns object hold by instance, variable which is inside the inner class.